Hello everyone, this is Iris, the ERMI Product Manager at AVerMedia. Thanks for joining today's Discover ERMI, Next Generation Outdoor Band Management for Edge AI webinar. We've got a great program lined up, but first, a couple of quick housekeeping notes. If you have a question at any time, please leave your message in the Q&A panel. Our team will be monitoring the Q&A panel throughout the session, and we will also address the questions live at the end. We are also recording this session. We will share today's deck along with the replay video later today. With that, let's get started. Here are your presenters today. I'm Iris Liu, again, the Product Manager for ERMI, and with me is Chen Ye, our ERMI System Engineer. I'll cover the first part of the webinar with guiding you to discover ERMI and the Outdoor Band Management for Edge AI, and Chen will lead the demo afterwards. Without further ado, let's get started. Thanks everyone for joining the webinar. Today, I will show you how ERMI Outdoor Band Management keeps Edge devices available and controllable, even when the device OS is down. So you get to recover the devices in minutes, minimize site visits, and therefore reduce labor costs and maintenance costs. Here is the plan for the webinar. First, we will cover what Outdoor Band is and why it matters. Then I will introduce ERMI, walk through the ERMI layers and its core capabilities, share a few success cases, and show you how to get started with AVerMedia Outdoor Band solution. We will also have a short demo hosted by my colleague, Chen Ye, and we will leave some time at the end for Q&A. So let's get started. As the project scales up at the edge, these are the two common problems that we see, and these are also the two costs that we want to minimize. Problem 1 is the field service on the left. A technician visit typically runs $50 to $100 per hour. And if you include all the travel, material, and admission, the costs add up to $300 to $1,000 per visit. And if we multiply that by dozens or hundreds of sites, the costs add up quickly. Problem 2 is the lost revenue and productivity on the right. Imagine that a self-checkout kiosk crashing during peak hour. If you miss 30 transactions at an average of $50 per basket, you will miss about $1,500 of sales. On top of that, we need to add $500 from customers not wanting to wait and therefore abandoning lines. At the end, we need to add another $50 to have extra staff coming over to cover the cashier. So that's about $2,000 for an 1-hour service downtime. These numbers are illustrative, but the problem here is that the cost is very expensive and we don't want that. So this is the problem that Outdoor Band is built to solve. We want to reach the device immediately and recover fast without sending someone over on site. With that context, let's define what Outdoor Band remote management is and how it works. So before we talk about what Outdoor Band management is, let's first check what the traditional remote management is and also its limitation. On the left, it is the traditional remote management, or what we call in-band. It runs on the primary OS and network. We install a software agent or we use SSH to access the device. Well, everything is good when the OS is healthy and the network is up. However, if the device freezes or there's something wrong with the operating system. You won't be able to reach the box to fix it. So that is why we need out-of-band management. On the right-hand side here, it is out-of-band. Out-of-band gives us a dedicated and always-on management channel that is independent of both of the OS and the primary network. With the ERMI module inside the device, this path stays available even if the OS is down or the unit is powered off. In-band is great when everything is normal, but out-of-band is the channel that we rely on when things are not as expected. It is how we avoid site visits and recover services in minutes. Let's define out-of-band in practical day-to-day terms. With a dedicated, always available out-of-band communication channel, we can reach the device immediately, troubleshoot faster, and cut both downtime and on-site support. This is especially valuable for projects that are located at hard-to-reach areas like traffic poles, rooftops, or rural cameras, where getting a person on site is slow and expensive. Now that we know what out-of-band is and why it helps, let's move to the technical side, how the out-of-band path works and how we make it happen. For out-of-band to work every day, we need to find a way to make the out-of-band communication, out-of-band control, and out-of-band management easy for us. And that is why I want to introduce you ERMI, the Edge Remote Management Interface. ERMI defines the path and the language for the out-of-band communication. It provides a simple and open standard interface that turns out-of-band control into fast, repeatable operations you can use in a portal or in your own tools. ERMI standardizes management across hardware platforms, including NVIDIA Jetson, Qualcomm, x86, and ARM architecture, and across deployments in the cloud or on-premises. This means that with a standard approach of ERMI, you can use the same management approach, reuse the same runbooks at every site, and recover faster with fewer site visits and more predictable operations. That is why out-of-band needs ERMI. Now, let's look at the solution architecture that makes this work. The ERMI solution architecture consists of 3 layers. Starting from the bottom, the device layer. It is a small ERMI module that is integrated with the edge device, and therefore creates a separate management channel from the device's original application path. Next, the control layer is the ERMI API. The ERMI API provides standard and consistent control between all the hardware in the device layer and all the management interfaces in the access layer. Lastly, the access layer. At the access layer, you can choose how to use it, whether you want to manage through a partner portal in the cloud, run a local portal inside your network for secure or air-gapped sites, or if you want to integrate with your own tools. Each of these options uses the same ERMI controls, so you can duplicate your management across all the projects. So now I will go over each ERMI layers in detail. First, I will start with the device layer. The device layer is hardware, the edge device, and the ERMI module. The existence of ERMI module is to monitor and control the edge device. The ERMI module is a standalone component that can be integrated with any brand of edge device. no matter it's NVIDIA Jetson, Qualcomm, x86, or ARM, Windows, Linux, or Android. The ERMI module is powered from the edge device standby power, making sure the ERMI module is always available even when the device is off or unresponsive. The ERMI module can also connect to the debug UART and other interfaces such as GPIO and I2C. We have just seen how the ERMI module is integrated to the edge device. The next question is, how does ERMI module get the network connectivity? Here are the 3 connectivity options, and depending on your application, you can mix them across all the projects. First, Ethernet. This is the simplest and the most common path. Plug an Ethernet cable into the ERMI module and you are ready. It is ideal for fixed installations like stores, intersections, and factories. For many customers, Ethernet option is the default. Second, NCSI. NCSI stands for Network Controller Sideband Interface. With ERMI NCSI option, the out-of-band network can use the same physical Ethernet port as the device normal network. The concept behind this is that the NIC, Network Interface Controller inside the edge device allows the ERMI module to share the same Ethernet port on the edge device, which means that only one Ethernet cable is needed for both in-band network and out-of-band network. So what is the ideal application for NCSI? When the network infrastructure is already built, or when the cabling space is tight. Adding another Ethernet cable is not feasible, and expanding the cabling will be expensive. The NCSI option here saves you from all the hassles, and you wouldn't need to add additional wiring for your sites or modify your network infrastructure. Third, cellular 4G LTE. Use this 4G LTE option for remote sites in rural areas or for mobile deployments such as robotics, where an Ethernet connection is not practical. This is also a good option when you want the out-of-band channel to be independent of the primary network. In that case, the ERMI module connects through its own 4G LTE network, and it remains reachable even if the primary network has issues. So, with all the network connectivity explained, we can now move on to the next layer, which is the control layer. The second layer is the control layer. This is the most important layer in the ERMI architecture because it is responsible for communicating between the device layer and the access layer. Downstream, it has to communicate with many types of edge devices. Upstream, it has to connect to multiple management interfaces. The ERMI communication is complicated, and that is why we need one consistent standard interface, the ERMI API. The ERMI API is built on the Redfish Open Standard from DMTF. It uses HTTPS and JSON, which makes it straightforward and easy to integrate. The key point here is that ERMI is not proprietary. There is no lock-in. The same API calls work across all ERMI devices and across all ERMI management interfaces, whether you want to run in the cloud or on-premises. Using a standard keeps the model consistent, simplifies automation, and makes governance easier as your fleet grows. With that foundation set, let's look at what you can do with the ERMI in day-to-day operations. Here is what ERMI enables you in day-to-day operations. First, power-related controls. You can power on, power off, perform a clean system reset, and use enforcement shutdown when the device is unresponsive. For advanced features, you can also open a remote serial console for accessing BIOS or UEFI, and terminal access for daily operations. You can also use AVerMedia to mount images for OTA or BSP updates and full operating system recovery. When needed, we also support customizations for your specific applications. In terms of how you can operate or manage, you get to choose to use ERMI Local Management Portal for on-premises environments, or you can use ERMI Partner Portal for plug-and-play fleet management. Or you can integrate the feature mentioned above onto your portal directly through the ERMI API. Next, I will show you how Remote Console and AVerMedia work together for early boot diagnosis and hardware level recovery. Remote terminal access gives a direct line into the device even when the operating system is down. Through the always available out-of-band communication channel, ERMI bridges the debug UART port from the edge device to your screen, so you can watch the boot sequence interrupted and enter UEFI or BIOS. From there, you open a shell for diagnosis, capture boot logs, change boot order, and check hardware settings. A common workflow is to pair this feature with power control actions. With enforcement shutdown and remote terminal access, you get to recover the device from a frozen state, perform deeper low-level diagnosis, and adjust system configurations. It helps you to find out the root cause faster and avoid a site visit. Next, let's see how AVerMedia uses the same path to run safe updates and full image recovery. If you need to update the BSP remotely or recover a failed BSP, ERMI gives you a safe path. Throughout the out-of-band communication channel, the ERMI module can present itself as a AVerMedia to the device. All you have to do is to mount a good golden image from a file server. Once the BSP image is sent to the edge device from the AVerMedia, the BSP update process will begin. And through the whole process, you can use the remote terminal mentioned in the previous page to monitor the update process. This is a unified approach, and it allows you to update BSP across many devices remotely and simultaneously. It reduces travel costs and avoids one-by-one updates. Now we have learned the ERMI API from the control layer. Let's move to the next layer, the access layer, which explains the ERMI management options you can use to access all the out-of-band functionalities mentioned earlier. First management interface is the ERMI Local Management Portal. All the ERMI functions are already integrated in the Local Management Portal, so operators can use power, console, AVerMedia, logs, and health monitoring all from a simple page. It is for on-premises use, which means that all the management traffic stays inside your network. This management interface will be a good fit for you if your project is for secure facilities and air-gapped sites. This is plug and play and is also good for evaluation and daily operation at local network. For fleets that prefer to use a portal in the cloud, we recommend our ERMI Partner Portal. The second management interface is the ERMI Partner Portal from Conateam. Conateam specializes in fleet management for robots and AIoT devices, and it provides a unified platform to deploy, control, and monitor fleets with built-in updates and analytics. Their portal runs in the cloud or on premises and comes pre-configured with ERMI for plug-and-play out-of-band controls like power on, power off, enforcement shutdown, and as well as remote serial terminal access. The connecting portal not only covers all the necessary features for remote robotic management, but it also delivers all the core device management functions powered by ERMI. The last interface is for deeper integration. If you have your own control center or your own management portal, you can use the ERMI API to integrate all the ERMI functions onto your portal. Here is the developer side, which provides everything you need for integration. There is API reference, quick start guides, and examples for functions like power control, serial console, virtual media, logs, health monitoring, and more. There are also copy and paste samples for your application and your team. Next, let's look at how other customers use ERMI functions at their production site. The first success case that I want to share is the outdoor surveillance deployment. This company runs unattended, high-security outdoor systems using AVerMedia JSON hardware. The challenge that they faced is that their devices are located in restricted area with no internet and limited physical access. When something goes wrong, a quick visit to the site is not feasible, and the downtime threatens the surveillance continuity. To fix this, they integrated the ERMI API onto their local control center, which enables them to safely power on, power off, reset, or enforce shutdown from their local network. They can clear device frozen states immediately from remote, keep the site compliant, and avoid going to the site physically. The second success case that I want to share is the multi-store retail analytics deployment on AVerMedia JSON box PCs. The challenge that this customer faced is that they often need to do the low-level diagnosis or to change the boot sequence. But accessing the UEFI menu is not available for traditional in-band remote management services like SSH. To solve this customer used ERMI serial overlay feature. The ERMI API bridges the device debug UART port to the ERMI management interface, so they can watch the boot sequence, open a terminal when the OS is down, capture boot logs, and enter UEFI to adjust settings or recover boot configuration. Besides changing the boot sequence by entering UEFI via ERMI serial overlay feature, this customer also used this SOL feature for day-to-day remote management. And the result? Issues are resolved remotely across stores. No more site visit, faster recovery, and easier day-to-day operations from remote. Here is another deployment story from a smart traffic project. This customer uses AVerMedia D115 5G for their project. In this project, the devices are located in roadside cabinets across multiple cities. Getting to any one of these sites takes about 4-hour drive, so a single site visit can easily consume an entire day. During the first rollout of hundreds of devices, everything looked healthy except for about 15-20 devices. These units were never appeared in their control center after the installation. No heartbeat, no SSH, no information, nothing. None of the traditional in-band tools was accessible. In the past, the only option for them would have been to send a technician over, spending a full-day round trip to open the cabinet and fix locally. However, Because the devices were equipped with ERMI module, the team took a different path. They opened SOL through the ERMI module, the out-of-band channel that's available even when the OS or primary network is down. From that remote terminal, they could watch the boot output and get straight to the shell. Within a couple of minutes, they spotted the issue. The devices had been provisioned with incorrect network setting, wrong IP address, and gateway. So that's why these 20 devices could never appear on their production control center. Once they found out the root cause, directly from this SOL session, they corrected the network configuration, confirmed the link and the routing, and restarted the network services. The devices were immediately reappeared in the control center. No site visit, no link closures, and no lost day for the on-site support. This is how this customer used ERMI at their projects. When in-band access disappears, they still have an independent backdoor to diagnose, correct, and recover, safely, remotely, and immediately. Okay, here is the last section before the demo. Let's wrap up by showing you how to start with ERMI. Here is the two-step view. Step 1. Choose your edge device. You can integrate the ERMI module to your own edge device. And again, the edge device can be any brand. It does not necessarily have to be AVerMedia device. It can also be x86 architecture or ARM architecture. The operating systems of your edge device can also be any of Linux, Windows, or Android. If you don't want to integrate the ERMI module on your own, you can select any of the off-the-shelf AVerMedia system with ERMI module built in. With either options of hardware selections, you get the same ERMI controls. Next, the step 2. Choose your management interface. We have 3 options of ERMI management interfaces here. First, the ERMI local management portal for on-premises environment. Second, the ERMI partner portal, the connecting portal, for a plug-and-play experience that can run in the cloud. Third, the API integration if you want to integrate ERMI inside your existing portal or script automation. All these 3 management interfaces use the same ERMI controls. Okay, these getting started steps might sound complicated for you. If you want to try ERMI solutions without all the hassle, here is our turnkey solution. This turnkey solution is presented by AVerMedia and Consulting. It consists of AVerMedia D115 Jetson device and pre-configured with Consulting services. With this turnkey solution, all you have to do is power on the device, enroll the device onto Consulting portal, and you will be able to access all the remote robotic functions as well as out-of-band features, all from one single portal. It's the fastest way to validate ERMI with your application and your team. This is the last slide before the demo. Before we switch over, I want to leave you with a few takeaways. ERMI keeps remote control available. An ERMI API is a Redfish-compatible RESTful API, which makes sure the communication is consistent across all the ERMI devices and all the ERMI management interfaces. You can run it in the cloud or fully on-premises depending on your applications. Downtime is expensive, and we don't want that. So let's get started. Talk to your AVerMedia representative and try the turnkey solution offered by AVerMedia and Consulting. Okay, that's the end of the presentation part. I will hand over to our system engineer Chen Ye to give you a walkthrough of AVerMedia functions on the ERMI local management portal. Chance, over to you.
Everyone, I'm Chen Xie, who is your technical support guy at AVerAI team. Thanks for your time for being here. Today, I'm excited to have the opportunity to introduce AVerMedia OOB and its application architecture, along with a live demo. Through this session, I hope you will gain a clear understanding of OOB remote management and see why it's something you need to adapt right away and enjoy the convenience it brings. This is a brief idea to what OOB remote management is and it brings us the benefits. I don't take much time on addressing this in details since we have a lot of information introduced by Iris. This is our hardware wiring topology connection diagram. And we will be using the D115W box PC for explanation and demonstration to ensure the ERMI module is correctly connected to the edge device and is receiving a stable power for reliable operation. The demo I'm about to show is all about the navigating and using the ERMI local management portal. Think of this portal as a reference application built entirely on ERMI APIs. Every control you will see power actions, serial console overland, virtual media, as comes from the same REST endpoints your team can call. That means you can refer what's on this portal and integrate ERMI into your own tools or an existing fleet manager. Everything here is API driven, same codes, same behaviors. So if you already have a management platform, you can use the ERMI API and bring these capabilities directly into your system without reinventing anything. All right, with that context, let me walk you through the key ERMI operations and show how they streamline day-to-day recovery and maintenance. Okay, well, let's dive right into the live demo and see it in action. I would like briefly introduce you to focus on the function available in the left side navigation menu. I'll give you a quick introduction to the three main functions menus as follows. The first one is the operation menu. The second one is the settings menu, and the final one is the security and the access menu. First, we have the operation menu, which includes several key items. The first one is device information. Here you can check the device model and BSP version and the OOB daemon version, as well as the network and MAC address information. And this is the OOB information show you that exactly the firmware version is. This is the device power operations. When your box PC gets malfunction somehow, we can go here for rebooting our edge devices. This allows you to remotely control the device power, such as power on, power off, and the restart for your edge devices. Let's do a quick demo for you. You can see I click the SO consoles, and you will see our device is alive. And we'll go back to the device power operations, and we select the false restart devices. And we click the action button and confirm that. And we'll go back to the SOL console, and you can see that our edge devices is rebooting now. We click the device power operations, and we select the false off devices, and we click the action button, confirm. And right now, the edge devices will be shut down forcefully. So even if I type in my keyboard, there's no responses. So as you can see, the screen is in black. Okay, so when the edge devices is shut down completely, and we go back to the device power operations, and we click the power on button, and right now the edge devices will be power on through the OB modules to get back, bring up the system up. So we go back to the SO console, and we can see now the edge device system is back on for process. Okay, this is very simple and useful functions. Now I'm going to show you what the SO console is and what benefit is for us. As you can see the screenshot, we have the edge device console screen. When it is not convenient to access the device on site, we can use the SO console to remotely connect to the edge device for data maintenance. So that's very useful for our clients to the maintenance purpose. Okay, so now I'm going to show you how we can access the JSON's UEFI through the SOL console. This comes in handy, and if the NVIDIA edge device runs into a problem, or if you just need to get into UEFI for any other reason. Okay, once we are in, we'll take a look at the boot channels manager. All right. First, we click the SO console, and we go into reboot the edge devices. Okay. All right. So wait for seconds for the edge device rebooting. And remember to press the F11 key to access the boot manager. Okay. As you can see, this is the boot UEFI menu. So go into the end setup, enter. All right. And we use the keyboard to pick up the boot maintenance manager. And the first item with options. Okay, and then go to the final one, change boot order. And as you can see, we have lots of options to boot for the UEFI order. So add enter, and we can choose the boot order. We can use the plus or minus key to choose the order, to arrange the order. Okay. Okay, now I'm set the UEFI share to be my first one boot order, enter. And we press the F10 key to save the setting. Okay, and we press the ESC key. Okay, can go back to the top level menu and press the enter for the reset. Okay, now edge device is rebooting. So let's see how it's going on. It should be enter the UEFI boot prompt. Okay, wait a second. Okay, as you can see, this screenshot is show you that we are going to enter the JSON UEFI prompt. That's it. And right now we reset. I wanted to set the boot order back to the our SSD inside the edge device. Okay, wait a second. All right, press F11 key and the same procedure and set up. Okay, boot maintenance manager and boot option. Change the boot order and enter. Okay, move selection down and press the plus key and enter. So as you can see that our boot order, the first one is SSD. This is SSD device name. So that's it. So, okay, we move the cursor right here, commit change and exit. And we press ESC key. One more time. Okay. Reset. Okay. Right now the edge device is going to bring up the operating systems. So we wait a second. Okay. So if you need to check the or to reconfigure the bootloader, you can use this functionality. All right, this diagram shows how a client can use the OOB modules, virtual media, and serial overland features to pull files from a remote file server and connect them directly to the NVIDIA JSON edge device for easy management and operations. The key idea is that with the OOB module, we can take advantages of its virtual media feature. This works through the APIs, so the technician doesn't need to be physically present at the JSON edge device. Instead, we can easily mount an image file like an ISO file directly from a file server. It's just like a copy and paste seamlessly and straightforwardly. The OOB module acts as the bridge, presenting that image to the NVIDIA JSON as if it were a local drive. With this setup, deployment becomes much easier, and because we can deliver the necessary image files to the JSON remotely, anytime and anywhere. All right, next, we are going to demo an example of how to use virtual media in practice. With virtual media, you can mount an ISO file or a disk image to install software remotely. It's just like you plug in a USB drive to a device, but the way is over the network. Okay. First of all, we click the SOL console and we issue a command. And there's no USB storage device information right here. It means that there's no mount any storage devices remotely. So there we go. We go back to the virtual media and we just fill the information. Okay. And type the password. And the path is already stored in the database. So just click the bound button. Okay. And shortly the message pop out, your successful connection. So we go back to the SO console. And now we send the send command. All right, and as you can see, we have another devices. It's called the Linux USB file back storage gauge. It means that you already have the virtual storage for your edge devices. So we can check the device name. Okay, as you can see, we have the device name is called SDA, right? And the capacity size is 1.9 megabytes. So next, we are going to mount the devices onto our edge devices. So type the command mount DEV SDA to media to USB. This is the file path we already built that already. So we just type this command. Okay. Okay. Sorry, I will have to use the admin privilege. Okay, that means you're successful to do this. So you can change your working directly path to USB and check see if you have the files on your edge devices. Okay, as you can see, we have two OOB daemon installation package. So we can do a trial to install the daemon program. So we can do this. Okay, go. So as you can see, the program process is going to install the daemon program service install pack. So we wait for seconds, and then the process will finish and to tell you that this software patch is installed successfully. Okay, that's it. So you can check AVerMedia. Yeah, that means we already installed the OOB daemon package successfully. Okay, that's the virtual media functionality, how we to build up this functionality. And then we can go back to the virtual media. And if we don't use that the virtual media function, we can just very easily to click on mount.
Okay, thank you, Chance. Thanks, Chance, for the detailed walkthrough of the ERMI local management portal. Now, a quick recap. We just saw how ERMI provides users a remote control access to NVIDIA JSON device from the local portal. Chance has demonstrated how to do the system power reset and enforcement shutdown. Also showed the serial overland feature for day-to-day checks and entering the device UEFI menu. Chance finished the demo with showing you how to use the virtual media feature to mount files from a file server via the ERMI module. All the features that you saw in the ERMI local management portal is also available through the ERMI partner portal or directly via the ERMI API. Now, let's move to the last section, the live Q&A. Please drop in your questions in the Q&A panel and we will take them in order.